given the equation y equals 2 minus the square root of x, find A, a list of a few of the ordered pairs x, y, B, a sketch of the equation, C, the domain and the range, and D, answer this question, is y a function of x? Part A, well, we're going to make a table. We're going to just choose some values for x, plug them into the equation, and calculate what the y partner is. So let's start with x equals 0. Y partner is 2 minus the square root of 0, which is just 2. So when x is equal to 0, y is equal to 2. Let's let x equal 4. And we can choose any x. I just chose ones that I thought would be easy to work with. X equals 4, plug it in, and we have 2 minus the square root of 4, which is 2 minus 2, which is 0. So we have the ordered pair 4, 0. And finally, we'll let x equal 16. Plug it in. We have y equals 2 minus the square root of 16, so it's 2 minus 4, which is negative 2. I said we could choose any x's, but if you examine closely this equation, there is an even index root of x, and there is a restriction on what x could be when you have an even index. So make sure that you don't violate the rule that you're not allowed to take an even index root of a negative number. So you notice I had no negative numbers as I selected for the x's. Part B, do a sketch. We're just going to use the ordered pairs that we found. We found 0, 2. Let's graph that. Let's graph 4, 0. And I'm not going to graph 16, negative 2. It's way out here. So let's just do a smooth curve connecting the dots. All right, it's not a straight line. No, it's not going to be a straight line. We're not exactly sure what it looks like yet. So we're just making a kind of a curve fitting the points that we graphed. Part C, find the domain and the range. Well, look at, we just said that there's no way x can be negative because you're not allowed to take the square root of a negative number and then graph the results because the results are not a real number. It's an imaginary number, and there's no place to graph it on our real number lines. So we have to choose 0 as the smallest number for x in the domain. We can have 0, that's not a problem, but we can't have anything smaller. So boxy bracket 0, that means we include 0, and we can go all the way up to any number that's positive, so all the way up to infinity with an open parenthesis. We never include infinities in our set notation, in our interval notation, because infinity is not even a real number. It's not included in the list of real numbers. The range, we're listing all the real number values in the range, all the y values. Well, look at the graph. The graph starts at its highest point at y equals 2, and then it's falling, 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 and we assume it will continue this pattern and never turn around and get any higher than 2. So the y values start because it continues to fall. We know the y values occur from negative infinity with a round bracket all the way up to 2 with a boxy bracket. And finally, the last part, D, is y a function of x. Well, look at the graph. Does that pass the vertical line test? And the answer is yes. There's no vertical line that's going to cross this graph in more than one place. So it means that all the x's in the domain of this function, and remember this is our domain, all the x's produce only one y partner, and we know that because it passes the vertical line test.